open LeetCode, but I will paste the link in a second.
Okay.
So let's. All right. Let me double check if we are live. Yeah. I think we're ready to go. Good morning, everyone. Hi,
Good morning. Good morning, Alex.
Yeah, welcome. XTCode Hour. It's a session of XTechnology where we either we solve some interview questions or we can different projects during this time. The idea is that we basically write in this time, so we don't prepare too much for this session. So today we have a spam in XTechnology history. Is Pavlik Kisilov. Pavlik, words about yourself.
Yeah, thanks, Alexei. As Alex. So yeah, I'm Pavlik. I'm working at ING for the last around 5 years. Working as the front-end developer, where we build the login team and everything around authentication. We work mostly with web components, and I think not even mostly, but only with web components. So, and how is it like this particular session? It's relative to me. So, when even before my career as the programmer started, I was interested in the so-called competitive programming, where you can just solve some computer science related tasks. And since then, I know and remember some data structures a little bit, some algorithms, and it's just like really fun to solve sometimes those tasks. So thanks, Alex, for inviting me.
Well, thanks for joining. Indeed. Last with this code shift, I think was a nice technology to transform abstract syntax tree features to some other formatted programs. Something like algorithmical tasks. In your experience, a part of a regular interview question session, or it's only for Facebook, like Google?
Yeah, unfortunately, I cannot like for sure say whether it's Facebook or Google, but yeah, most probably they do have some computer science. In my interviews, I don't do computer science tasks per se, but there is a like whiteboard small task, really small for like two. You need to call two functions basically on array, but that shows enough information for me whether like people understand the coding in general and can code. And specifically about computer science, I myself do not often see those tasks in my daily routine. However, time to time that happens. For example, like lately we needed to analyze the dependency tree of the projects and their dependency trees and their dependency trees. And of course, basically, you would need to traverse the graph of dependencies. And for this, it's good to have a knowledge how to do this reliably and efficiently. Actually, so yeah, rarely that helps, but not very often, I would say.
Yeah, I see some comments by Jonathan. Hi, hey man.
Hi.
Yeah, cheering. All right, so we are ready to start, I believe. We have to see how many actually we can do. I think I selected 4 as a maximum with a medium. So let's see. I propose to begin with this one. It's called David. See this one?
Yeah. daily temperatures. Okay, given an array of integers, temperatures represents the daily temperatures. Return an array answer such that answer with index I is the number of days you have to wait for the ith day to get a warmer temperature. If there is no future day of which this is possible, keep answer I 0 instead. So as an example, we have temperatures. I guess they're in kelvins, so it's from United States. I hope. So then in the first from the first day to the second, it's immediately higher temperature. So from the second to the third, another higher temperature. Then okay. So then we need to wait for 4 days. And this is from 75 to 76. And then there are no days where we can have a higher temperature. So,
by the way, sorry to interrupt your thought. A little bit bigger, just one time bigger, maybe one.
Yeah, sure. Is this good? Okay.
Much better. And the second one, I know that you have been solving LeetCode for quite a while. Is this a new one to you, or you already?
No, this is a new one. Yeah.
Okay,
so
yeah.
Okay, so my initial idea, for example, would be to keep the maximum temperature and then basically check each index. If it's a maximum temperature, then add to the answer the current number of like days in a row that it was not a higher temperature and update the higher temperature. So we need to define the answer first, which will be an array, an empty array for now, and we need to define our temporary variable for the higher temperature. So I would call it max temp, and then okay, so I will check the constraints, and I see the temperatures cannot be below 30, so I'm safe to assign to the max temperature initial value 0. And I'm doing this because the first item in the array should always be bigger than the max temperature. So, and also I can see that the first input is 1. So, okay. So then the cure days will be 0. Now I'm going to iterate through the temperatures array. And on each iteration, I'm going to do current days plus 1. Okay, so I will need to check this basically because it's not always the case that it should be done in the very beginning. But what I can do for sure is then check the current temperature. And if this is the bigger than our initial value, then what we do, we assign it and we update the answer. And the answer push the cure dates. Now the most interesting part. So in the examples, I can see that the first one is always 1. So the first day always signals that it's like it's higher than the starting temperature. So in our example, the first will be immediately 0. However, in the same time, I cannot assign it as deleting like 0. as the initial value to the current days as 1, sorry, because then sometimes when there are zeros, it will not be working. But no, it will be. So so what I can do, I can assign here 1, but also if it's not a bigger day, then I need to actually keep count of the days. Why do I need this? So if it's not regular big, or if it's like the end of the array and there are no bigger value till the end of the array, that what would happen here is that we will reach the end of the array, we will not find any bigger days, and we basically put everywhere, we don't put anything anywhere. So the idea is that we need to keep count of the days also in the end of the array where the values are lower than our max temperature, and in the very end check whether it's like there are days in the end of the array. So for this I will do also something like
ask maybe something. Can I propose something?
Yeah.
Like I think we're now in a deep to solving that technically. Can you maybe explain on a high level how what is your algorithm, like what is the business logic that you're trying to implement?
Yeah, so the main idea is that we're not really applying any algorithm here, like any specific well-known algorithm. And our solution is to just basically try to do whatever it's set in the task. So we need to collect the number of days we have to wait until the day is bigger. So we will keep this in the cure days variable, and then once the day, the temperature of a day is bigger than the last previous collected temperature, we update the max temperature, and we also just save the current streak of the days. And if it's not bigger, then we just increase the number of days. But what I also want to check is that here.
Yeah, I think why I asked you that because I think maybe we reread the description. It looks to me a bit different exercise. Like you need for each day in the array, you have to produce exact number of items in an array, but each item
no.
to wait.
Yeah, you're right.
Yeah.
Actually. So for each day, that's what indeed, like we have the same number of inputs and the same number of outputs, and indeed for each day we need to check on each day the temperature will be bigger. And this is a little bit different then, and so basically then we will check the constraints one more time, and the solution, like the easiest solution would be just to reiterate an array. So we check the first day, that's number 73. So we check the array till the rest when the number is bigger. So this is the first one. Then we check 74, this is the first one. Then we check 75, this is like the fourth, and so on and so on. So the problem with this is that we have 10,000 of the max number of elements. And because this will be a nested loop, the complexity of this will be something number of elements in the power of 2 because of the nested loops. And the 10,000 in the power of 2 is too much for us to work with. So that would be 1, 2, 2, this. and 100 millions. And I think the execution time of this will be too slow. So we need to find something more efficient. So then let me think a little bit how it can be more efficient. Basically, there's can be another idea that we can use. We can basically optimize it in a little bit different way. So the temperatures are only 100 of them, or even like 70 if we don't take the initial temperature. So then we know that for 30, the temperatures that are bigger is 31, 32, 33, etc., etc. So we can actually keep those temperatures in a separate data structure and only check their indexes. So then okay, so let me think whether it will be an optimization or not. So let's assume we have indeed 30, and then we need to find okay, and we can index those arrays by no. Yeah, let me think a little bit more. Because initial idea was, okay, so we have, let's say, data structure, something like temp by indexes, and we keep here, for example, 30, and we keep that this 40 is on index 5, 4, 5, 6, and let's say 10. Then we have temperature 40, and then we keep it, then it's like index 2, for example, then 7 and 8. So for each item, let's say in the array, current temperature is, let's say, 45. We can check, okay, how many indexes are 46, 44, 46, temp by indexes 46, then 47, then 48, etc., etc., etc. So I think there's like the solution will be somewhere in this direction. So like it will be some preparation of the array in the first iteration, and then actually for the each item, for each index, we will find the answer. And now I need to know what will be the preparation on each item. So how to convert this data structure, this array of numbers, to something that we can efficiently use to get the number of more bigger elements till the end of the array. Okay, so I'm thinking about right now about some data structures like heap, maybe, of binary tree. And if on each item we will put this to binary tree, and then we can check. No, we cannot. We will need to check the rest of the array, which is not yet in binary tree. So okay, let's then check what other data structure we can use. For example, set. Set, or maybe even linked list. Let me think if we can use a linked list here somehow. So basically on yeah, for linked list, after we will linked list also not the most suitable idea. Okay, then it should be somehow be iterated as an object, and can it be? So what I'm afraid, okay, so like let's assume we can do this like this. And then on each iteration, we will have for 10,000 elements, we will go through 70 numbers. But then for each number, we would need to go through all indexes like there. And then it can be also 10,000. because, for example, in the very first worst case, we can like have an array of like 30, for example, and then 10,000 of 30s, like 30, 30, 30, etc., and then 10,000 like this. And the problem with this bullet, then, like we have for each 30, we will go through all 70 elements, we will find another 30, or for example, not even 30, but like half of the array is 30, half of the array is 31. So we will find 131, and then go through the all 31s to understand whether the indexes are bigger. And then for that will be the worst case is 5,000 per 5,000, I think. And this is 25 millions, I think. It's a little bit an improvement. It's like 4 times, but it's still not ideal. I'm by the way, yeah, four times. But it's still not ideal. So is there any way we can do this faster? So there should be a way, definitely. And with linked list, what I thought initially is that, okay, we can keep them sorted. And then for each iteration, we will search in linked list this element, and then we can go just one by one till the end of the array, and then it will be optimization here, for example, but not in the rest of the places. What I'm thinking another thing can do is try to, for example, group maybe. Group them like this. So, but instead of the object, we can have an array. For example, and then what would it do for us? Yeah, okay, so then it's a little bit optimization, but yeah, it's a little bit still optimization. So yeah, but the grouping will be expensive for us. Okay, so that also doesn't work. So by grouping, I meant, okay, we can go in a given example. This is the best example. So we can go through the array and see, okay, 73, and this will be index 0, and the last one, for example, 2, 3, 4, 5, 6, 7. Then we can see that 74, and this only index 1, etc., etc. So then we can go through this array and see for each element how many indexes are bigger than the current index. But that's a little bit, yeah, that's what I meant by grouping, but that doesn't really help. Okay, so what other options we have? We definitely should use the fact that there are only 100 of elements. So how can we use this fact? How we can use this fact? So maybe what other data structures we have? So maybe we can just sort them first, and then we somehow don't need to know the result, because basically the condition should be that we increase for each element, we increase the answer if there is bigger number with bigger index. So if there's like 100 elements or 10,000 elements index-wise, but there is only 100 or 70 number-wise. So maybe we can use this fact, and maybe we can somehow switch to going through numbers instead of the index. And that's, yeah, a little bit continuation of this idea, but I just don't know how to expand it right now. So let's assume, okay, we can group them, for example, like this. So there will be 73, and it will be 0 and 8, and it's like 74 with just 1, 75 with just 2, 71 with just 3, 69 with just 4, 72, there was no in the array, 72 with 5, 76 with 6, and 73 already was there. Okay, so let's assume we can sort this array. So there will be 69, then it will be 70, no, 71, 72. Okay, I can see 72. Has there two of them? No. Okay, 72 then 5, 73, 74, 75. So this will be 70. 72 is 6, 5. This is 72. And 75 is with 2, so there will be 75 here. Okay, so can we use somehow this data structure to collect the results? So assume we go through them, and then for each iteration, we should check how many elements, how many indexes in the rest of the array. So essentially, we will have the same number of indexes and the same number of groups. So I don't see yet how it can help us for optimization, because we will go through 100 elements in a loop, so 10,000, but there will be also an inner loop where we will check each number of indexes. For each group, we will check the indexes. So that doesn't really help. So what else we can do? What else we can do? So since the time is running, what I'm going to do first, I'm going to implement just a not optimal solution.
And squared solution.
Yeah, and squared solution, and then I can think how it can be optimized. So this.
Yeah. I really like the different structures that you mentioned, but in my opinion, it's also the most straightforward for now.
Yeah, exactly. So if this is bigger than the current one, so current days is 0, and okay, so current days 1 actually. So if we collect them and then increase the current days, then we check if current days is 1 and we didn't find any bigger elements, then the answer push 0. If we find okay, and then So what I'm going to do, actually, I'm going to put. Okay, so that's not the yeah, okay. If it's lower, then we need to increase. If it's higher, then we break. And then in the loop, if we have increased them, okay, so if in the end of the loop we did not find any elements, but let me think how we can check this. So the first one, what we do is cure days, and now let's think a little bit. So that's our example. So 73 and then 74. So we find immediately 1, we break, and then we push 0, which should not be the case. Okay, so let it be 1. So then, okay, we found 1, we break, we push 1, we found another one, we found another one, skip, then a 2, 3, 4, we found, break, answer is 4, answer is 2, answer is 1, 1, and then this one. So if it's lower, yes, it's lower, and then lower another one. So we also need to have a flag has smaller false. If we come to a break, then has smaller was true, and then if it has smaller, then we push, otherwise we push the 0. All right. So and then return answer. So let's validate against like another input. So 30, it will be I equals 0, and then temperature equals 30. Temperature I, let's say. Here it will be J will be 1 and 40. So is 40 lower than 30? No, 40 is bigger than 30, then has smaller true and break. So then here we have 0 has smaller true, and then the number of days will be 1. Cure days is 1. Okay, so then the second element, and it's 40, and here with this it will be 50. It's smaller, 50 smaller than 30? No. So has more true, and then another current days is 1. Then we will have 2, 50, yes. And then here is 2, and I is 3, the last element in the array, that is 60. Cure, another current days 1. And then the last element in the array, we don't come to the loop because 4 is bigger than, it's not smaller than the number of temperatures, and then has smaller is false. And then we will go here, and it will be 0. This we're not interested in, has smaller false, and then 3. Okay, and our result will be 1, 1, 1, 0. So that seems correct, actually. So I can try to run this just to validate on, for example, yeah, okay. If I submit it, will it execute our task? Okay. May I ask, so I can sign it, for example, or can just, yeah, I will try to sign it. 1 second.
Yeah, I to be honest, I the flow with a LeetCode when you have to submit only authorized or something like that.
Yeah, run code. Okay, so let's first run this and sure. Okay, so that feels good. Seems good. Now let's. Okay, so there is a wrong answer in this. Okay, for some element there is somehow the wrong number 1 and expected 3. So let's just validate this input. So 49, so it's expected 8. So then it's 8. Then for second element it's 1. For third element it's 5. Then this is 4. And this is expected 3. But we have, yeah, so then condition should be like this. Yeah, let's validate. Because there was exactly, okay, so this is a success, and actually that's runtime is very fast. So yeah, unfortunately my calculations about the complexity was not really efficient, or maybe LeetCode tests are quite forgiven in this regard. But yeah, probably there is a better solution. I'm pretty sure there is a better solution, and that can just yeah, do not go through the array every time. But yeah, if it works, it works.
Are there any hints on this task that we can check maybe for alternative solution? So now it's n squared complexity, and see how we can optimize it a bit.
How we can optimize? Yeah, that's a good question. So that's the biggest question to me. I did not find a way how to optimize it yet. So it's like n square complexity and yeah, but probably like my assumption like for the result is then like we will go through the temperatures first, and we'll prepare some data structure that suits for this purpose better. But like unfortunately, I cannot come up with some data structure for this.
So you were thinking like a tree that keeps well, first of all, and each node contains indices of where this particular is met in the input, right?
Yeah. Some, for example, that is this tree, but I did not find it useful because we still have the same number of indexes. Though then I gave it a thought, however, I did not say it out loud. Maybe some heap, for example, or the binary tree indeed. And the binary tree, so like on the binary tree, it will be that all nodes on the right are bigger and not all nodes on the left smaller. So yeah, so with this, we should like for each index, we don't need to go through the whole array. We would need to just go to the like the calculate the number of elements in this tree node on the right, and then it will be faster. And however, like the confusion to me came that first of all I cannot write the binary tree fast, and the second is that okay, but we also need to find where this element in the tree is. So then we will need basically to yeah, first of all to search in the tree for it. And second is also a little bit confusing to me is that we have some similar elements and also their indexes should be bigger. So okay, even if we build a tree and we know that on the right all elements are bigger, we don't know whether there's like their from they're like on the right side of the array, so it's a future days and not all the days. So maybe there is something in this. Maybe I can just like, if I'll give it a little bit more thought, maybe it's this like binary tree can be working. Maybe ideally it's like we can build it from the right side, for example, and then for each element we can for each next element we can just see in this binary tree how many already bigger elements there are. And actually, yeah, maybe this is a better option indeed. So if we just go through the like from the right, and let's assume, so we have this, and that's for each element. We will need to check how many already in the array with the bigger index. And yeah, and in this binary tree, so yeah, probably that would be a solution. So we would need to go from the right and build simultaneously a binary tree. So I will draw how it would look like, and then yeah, I'm not going to implement it, but just like drawing the idea. So for example, the first from the right is 73, then 76, and our binary tree would look like this, 76, and then we have 72, and our binary tree will be something like 72 here. And for 72, we already know that there is okay, but we will need to calculate the path to this to the closest bigger node, and I'm not sure for binary tree that it's like the parent. So yeah, maybe there is something in this, but on the top of my mind, I cannot come up with something like interesting for a binary tree, how it can be useful.
Right. Yeah. Anyway, so we solved not the best rate, but yeah, that's a good.
Yeah.
So what do you want to maybe try solving another one in a way? I think I have a simpler one. That one was a bit difficult.
Okay. Yeah. Let's try another one.
It's called find the duplicate number. Well, from the description, like it's a bit simpler, but let's see how it.
So this then here. Okay, given an array of integers containing n plus 1 integers, where each integer in a range of 1 to n inclusive, there is only one repeated number in nums, return this repeated number. Output 2, output 3, and what is the input? Okay. Oh, yeah, that's a little bit. You must solve the problem without modifying an array of number. Use only constant extra space. So this is the most interesting part. Without modifying and having like constant extra space. Why is it so? Because we basically the original the easy solution is just to create a map that will contain all the numbers. So for example, cache or existent or nums, just numbers. And then that will be an object. And then for each number, we just check. Okay, so I will do the regular for loop because I want to return early. Minus that nums length plus 1, and then if ns I then return if no, yes, if NS returns not I but nums I returns nums I, otherwise NS nums I equals true. Simple and straightforward, and uses the number of elements space. So how we can optimize this? So basically, what we also know that all the integers are different. So then, without modifying an array. So another option would be to sort an array and check the closest numbers. But yeah, the sorting is can work here according to the constraints. But let's think first whether there is a better solution. So what I'm also considering is to do some kind of binary operations with numbers. So let's assume we have 1, 2, 3 elements. So binary representation would be 0, 1, 1, 1, and 1 dot 0 and 0, 0, 1. So what we can do here, for example, if we do XOR of the elements, can we eventually get this element? For example, if we do just OR, then we will have always the biggest number. But if we do exclusive OR, then here will be 1, 1, and 1, 1 is exclusive OR, it will be 0. So is there's always like this? So then it's 0, 1, 1. And then, so this will be 1, 1, and 0, 0, it will be, no, it will be 1, 1, 1, probably the answer. Okay, so then it can be depending on the number of, depending on the number of whether it's even or odd number, the result can be either 0 or the biggest element. Let's validate this. So then we have 1, 0, 1, and we already know that we will have something like this, and this will be 0, 0. No, that's not also true. Okay, so the binary magic does not help us here. However, it's just yeah, sometimes it helps. What else we can do to use the constant space? Okay, another interesting option is to actually get the sum of these numbers. So this is still under the constraints. So we can just go through all of them, and then we can use the fact then sum of the n numbers should be n multiply n plus 1, and then divided by 2. So essentially, the answer will be 1, 2, 3, 4. So essentially, the answer will be their sum minus this number. So let's check this. So const s equals nums reduce and sum and n, and then we return n plus sum, and it starts with 0, and then return total sum minus number of elements multiplied by the number of elements plus 1, and then divided by 2. So let's check this. For example, for the first input, our sum will be 4, 8, 10, 12. And we know, okay, so it should be not the length, but length minus 1 and regular length. Okay, so we know that the sum of elements from 1 to 4 should be 1, 2, 3, 4, which is 10. And we have here 12, so the answer will be 2. Now the next one, next example. 1, 2, 3, 4. Again, we know that it's like 10. And this is 4, 7, 11, 13. So the answer will be 3. So that seems right. So let's check whether it's right or not. Submit. Ron, okay, it can be different. It can be not one answer, not one number the same. It can be multiple numbers. Only one repeated number, okay. So it can be 2 repetitions, can be 4 repetitions, etc., etc. Okay, so that was a good attempt. That was working for the examples, but it was totally wrong. Yeah.
Brilliant idea.
Okay. Yeah. So now check this. How we can use a constant space. Okay, so let's return to this binary magic, for example. Does it give us something? Okay. Yeah, so for example, here we will have 0, 1, 0, 1, 0, 1. Here is constant space. So we go through all the elements and we somehow modify only one entity. So for example, it can be one number, or it can be, the only thing it cannot be a growing object. So there is something that we need to modify in place. And okay, so is the binary implementation. And we also know there's 10 in 5. Yeah.
Yes, for constant space and for binary magic, indeed, a number which is a number length plus 1, I guess, in binary radix, and then each bit basically signalizes there is a such number or not.
Yeah. So you're saying on radix nums plus length, right? So on this radix. Yeah, and then it will be the constant space because it's just, yeah, that should work. Okay, so, well, okay, so this and this flag, we modify this flag and then set whether it's already there, but how to modify this flag. Okay, so let's assume we have indeed like 5 numbers, then our will be radix will be 1, 2, 3, 4, 5, or then the number 5 will be represented. The number 5 will be represented in the yeah, it's just will be 5. Oh no, but it's, you're saying, so let's say we have 5 numbers, and then we convert it to the, we have a flag container that is based on the 5 radix 5.
No,
and then
no, it's a binary number. I thought, at least in my mind, it was like a binary number. In this case, 5, right? But and then this number should be containing zeros or ones if the index present there or not. But yeah, I think you also got the point.
Okay, so then it will be like this, and then the only thing I'm struggling. Okay, so there's like, let's assume we have the same number, and every time when we will modify, I don't know with what to compare. So we will, like, for example, use 4 here, and after the first iteration, we will have 1, 1. But then if there is like another 1.0, so I don't know how to basically use this binary representation and to check that the number is there.
Okay.
So this is
the other way around, like is a 0 or 1s, and this 0 or 1s, 0 or 1s is the length of input array, and then each in this number is a flag. Actually, I think that would fit.
one more time. Sorry.
So we have it should have a position, a number of position of the length of the input array. You have to type, for example, 000 input array.
Yeah. Okay. Yeah, that's what you mean. Okay, so idea is then you align everything like this, for example. Right, and then you have basically a string which will be something like this.
No, not really. But I also don't want to interrupt your solution. So let me try one more. So we have five lengths: 1, 2, 3, 4, 5. So we for our a 5-digit by a number, 0, 0 as a start. So 5 zeros, and then each time we need to identify the index. Well, we will put 1 if this number.
Something like this.
Like that.
Something like this.
Yeah.
Yeah. And then basically we can just okay, so we will need essentially to create yeah, so like you said, it's not like it should not be binary representation, but it should be a representation in the radix of the nums plus lengths. And this is, and then we can
like
check.
line 14 indeed is like when you meet some number, you modify index flag on this position, like what you typed.
Okay. Okay, but yeah, so I understand probably yeah, so there is like then should be something like this. We are running out of time, so like the pseudocode will be create a flag based on number of nums in this radix. So then for each element we check, for example, for and I think if and flag, if numbers e and flag, then it exists already and we found it. Otherwise So that will be like this. Else flag equals flag, and then or nums e, something like this. And then for each iteration, we will modify the flag and increase it and set this bit. And then once we
just
find
as
this,
if we meet,
yeah. Okay. Yeah, that's that's
is extra space used in this case? I think it sort of is, right?
So it is, but it's constant because for each you will have only one number for a flag, so it's a constant space and it does not depend on the number of elements. So that's constant space. Nice.
It depends on number.
Yeah. I would come to this solution. Yeah, a little bit later, maybe in 24 hours or something. But it's a good one. Yeah.
No, come on. Thanks, Paz, for this session. Yeah, of course, you welcome any to repeat this exercise. Yeah. Stay. Next week, I think we're gonna continue with the TypeScript Nest.js. We already have a few sessions about. So yeah, please, have a nice code.
Yeah, thank